Right, on to our second geometry chapter. Similar triangles, circles and theorems. So we'll start with similar triangles. So the last section we were talking about congruent triangles, and a congruent triangle means the shape is exactly the same. And we came up with the rules for congruency. Side, 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 angle, side, or right angle, hypotenuse, side. Those four. Okay. The one which we left out, which we discussed, was angle, angle, angle. Because you can have a triangle and have a bigger triangle, and all this angle can be the same as that angle can be the same as that angle can be the same as that angle, but they're not the same triangle. So they're not congruent necessarily if all their angles are the same, but they are similar. So here it talks, these are similar shapes, these are similar shapes. We were going to be talking about triangles. And you can see in this triangle down below, all three angles are the same, as in that's the same as that, that's the same as that, that's the angles, the corresponding angles are the same. So similar triangles have the same shapes but are different sizes. So it's exactly the same shape but different size. So I'm going to get you to take down that and that, similar triangles, that, what similar triangles are. What equiangular means, all the corresponding angles are equal, and that's what happens in similar triangles, so take down that. And the theorem, if two triangles are similar, then their sides are proportional. It means that if AB is double DE, BC is going to be double that, and AC is going to be double that. Or if this is 4 times the size of this, that'll be 4 times. Each side will be proportional to the other. So you have 3 yellow boxes to take down there, and the diagram is the triangle. And the converse of the theorem is also true. If the sides of 2 triangles are proportional, then the triangles are similar. So if we look at the sides, then we can say that they're similar. Okay. So 2 triangles are similar if 2 angles in one triangle are equal to 2 angles in the other, because the third must be also the same. If you have 2 angles, the third must be the same as well. So what we're going to do is we're going to do a couple of examples, and we're going to use this theorem stating that if one side is in proportion, the other sides must be in proportion. And we're going to do the 2 examples, and then I'll give you some questions to do. Right, so I'll just put that over here. And the first example. So this is the example in the book, and it can either tell you through symbols or through angles, actual numbers, that things are similar. So first of all, you have to establish, because in the question it might necessarily say they're similar. Obviously we're doing similar triangles now, but in the actual exam, are these similar or are they congruent? They're obviously not congruent, they're different sizes. So similar, this is the same as that, because they're both marked the same. This is the same as that, both marked the same. And this angle, these are similar triangles. Okay, so if we go back, similar triangles, it means that their sides are in proportions. So this side will be, this side compared to this side will be the same as this side to this side. So what I do, and again it might be done slightly different in the book, I try and find the proportion that the sides are. Okay, and I call it the scale factor. What scale has this triangle? This is obviously a smaller triangle. What scale has this triangle been multiplied by to get this? So you need 2 corresponding sides that have lengths in them. So we have a 4 here, we don't have anything here. We have a 5 here, we don't have anything here. But we do have a 9 and a 6, and they are the corresponding sides. So I say the scale factor, SF, is 9 divided by 6, which is 1.5. Okay? So this triangle, every length in this triangle has been multiplied by every length in this triangle has been multiplied by 1.5, because if this has been multiplied by 1.5, because they're similar triangles, this to get to this will be 1.5, this to get to this will be 1.5. Now we see what they ask us. They say find DE. DE. DE is this length. This corresponds to this side, and it's bigger, so it's obviously 4 multiplied by the same proportion, 1.5, and that is equal to 6. It doesn't give us any units there, it's just 6. Then the second question asks us is DF. So you can put in your diagram, you might have to use these, so that's 6. Then it says find DE. Now which side is DE corresponding to? It's this side, AC, and it's obviously bigger, so it's in the same proportion as the other 2 sides, so again must be multiplied by 1.5. So that's 5 multiplied by 1.5 is 7.5. And the way I do it, I always work with, I find the scale factor and then I decide whether I'm going bigger or smaller, to whether I multiply or whether I divide. When you look back at your answers, if you saw that one worked out to be 3, you'd know it's wrong because it has to be bigger than 5. Right, do the second example. Second example was this one. Okay, it's just rubbed out a bit there. This is 43, 6 centimeters. Right, we have two triangles here. It says, show that they're similar first of all, and they're similar. You just have to show that two of the angles are the same because the third one will be. So they have AC 43, AC 57. But if we work out either this angle or this angle, we should be able to clarify things. So if you add AC and 43, you get 123. Take away from 180, this is 57. Okay, so for the first part, you've now shown, and this must be 43. They are similar triangles because all their angles are the same. Okay, so that's fairly simple. Part 2 is what I'm more interested in. It says, find the length of FG. FG is this. So we need to find two corresponding sides. This FG obviously corresponds to the 5 centimeters. We need to find two corresponding sides. We have a 6 here and we have a 15 here. So I find the scale factor. What has this been multiplied by to get? What has this been multiplied by to get to this? So it's 15 divided by 6. That goes in 2.5 times. So this every length in this triangle has to be multiplied by 2.5 to get to these lengths. So now FG is obviously corresponding to BC. So that's 5 centimeters multiplied by 2.5. That's 12.5 centimeters. Now, they haven't done this, but say, for example, so this is 12.5. Say they now gave us this angle as, or this line as somewhere between, say it was 14 centimeters, and they asked us to find AB. Now they don't ask us in this, but say they had given us 14, they asked us to find AB. I would say AB is 14 centimeters. Now, if I multiply by my scale factor, it's obviously going to give me a bigger number. This is a smaller triangle, so if you're ever going from the bigger to the smaller, I would divide by the scale factor. And 14 divided by 2.5 is 5.6. Okay, because you can see this side is obviously going to be smaller than this side. And if you multiply by 5.6 by 2.5, you get back to 14. So that's similar triangles. You show the angles, the three angles will be the same in the triangles, and you just have to find a corresponding side that you've got both the values of. Find what the proportion that side has been multiplied by. I call it the scale factor, you don't have to. And then either multiply or divide to find the missing sides. Okay, so I'm going to give you a few questions. Please ask again if you have any problems.